Alright, 16B students, this is the same region as the previous shell washer video, but now revolved around the y-axis. So it's still the function of the region bounded by y equal to 4x and y equal to x squared. The points of intersection are still 0, 0, and 4, 16. But now we're going around the y-axis. And so here's the thing to remember. When you're going around, whatever axis you're going around, if you're using a strip that's parallel, so in this case a vertical strip is parallel to the axis, that's going to be the shell method. If you're using a strip that's perpendicular to the axis of rotation, then you're going to be using the washer method. So let's do the shell method one first. And again, well not again, I would say if I don't have a reason to change it, I usually try to keep things in terms of the variable I start with. So my functions are functions of x, right? Y equal to x squared and y equal to 4x. And unless there's really a strong reason to change it to x as a function of y, I might just leave it like this. Which means if I'm using x, I have to use a vertical strip. If I'm using a vertical strip, I have to be using shell method because I'm parallel. So once you decide the strip you're using, your method is automatically decided based on how your strip is oriented to the axis of rotation. So in this case, see that my radius, right, the distance of the strip to the axis is just x, right, because it's a horizontal distance. The previous one, the shell method, the radius was y. And the height of my strip is just the top minus the bottom, right, because it's a vertical strip. In the previous problem, it was the right minus the left. So then my volume is the integral of 2 pi times r times h, right? The volume of a shell is 2 pi r h dx. There's my r. There's my h. And we're going from, let's see, so it's in terms of x, I'm thinking about how far left and how far right this can go, or what the x values are on the limit of integration or the point of intersection. So from 0 to 4. For the shell method, you almost always have to multiply things out. So do 2 pi integral from 0 to 4. X times 4x is 4x squared. X times x squared is x cubed. And we end up getting 2 pi times integral, this is 4x cubed over 3. Integral, this is x to the 4th over 4. And a lot of these problems kind of work out this way where I'm going to plug in 4 and look, I'm going to get 4 times 4 cubed, which is 4 to the 4th, minus 4 to the 4th. So I know they have different denominators. You can say, oh look, I've got 4 to the 4th over 3, minus 4 to the 4th over 4, and I can factor out a 4 to the 4th. So it's 2 pi times 4 to the 4th times 1/3 minus 1/4. A third minus a 4th, that's 4/12 minus 3/12, which is 1/12. So I've got 2 pi times 4 to the 4th over 12. I can cancel one of those 4's right there. So I have 2 times 4 cubed. 4 cubed is 64. 2 times 64 is 128. So I end up with 128 pi over 3. And I should get the same thing using the washer method. So here using the washer method, I have to, since my strip is perpendicular to my axis of rotation, it's a horizontal strip, I know I have to be using dy, because again, the horizontal strip, right, the thickness of that strip is a small change in y. Just like the thickness of this vertical strip is a small change in x, a dx, if you will. So, for this washer method, the volume is going to be, well, it's pi times big R squared minus pi times little r squared, all times dy in this case. So the total volume is going to be the integral. Again, we're going from y equals 0 to y equals 16. Factor out the pi. And we have big R squared. So square root of y. And I have to change things to be functions of y. So the big radius is the function that's further from the axis of rotation, which is y equal to x squared. Or solve for x equal to the square root of y. And the little radius is the function that's closer, which is y equal to 4x, which becomes x equal to y over 4. Okay, we simplify. So we get pi times the integral from 0 to 16 of square root of y squared is just y, that's nice. Y squared over 16. Okay, so let's integrate. I get y squared, oh, don't forget the pi. It's really easy to leave off that pi. So we get pi times y squared over 2 minus y cubed over 3 times 16 is 48. From 0 to 16, So let's see, what have I got here? I've got pi times 16 squared over 2 minus 16 cubed over 48. 48 is 16 times 3, so we can cancel one of the 16s here with one of the 16s there. Then I've got a 16 squared and 16 squared, so I'm going to factor out a 16 squared times pi times 1/2 minus 1/3. That's 3/6 minus 2/6, which is 1/6. So we've got 16 squared, which is 256 pi over 6. Cancel a 2, you get 128 pi over 3. So either way you do it, you should get the same result numerically. It really just depends on how you want to do it. So I'm going to say one more time. Once you know the axis of rotation, you have to decide which kind of strip you're going to use. If you use a strip that's parallel, you automatically have to use the shell. If you use a strip that's perpendicular, you automatically have to use the washer or disc method if there's like nothing, right? There's nothing missing from being its axis. And if you use a vertical strip, regardless of the orientation, you have to use dx. If you use a horizontal strip, you have to use dy. So if I'm going around this way, if I want to use dx, I have to use the shell method because I'm parallel using a vertical strip. Whereas if I was going around the x-axis and I wanted to use dx, I'd have to use the washer method because my strip would be perpendicular to my axis. So that's kind of the method of choosing which thing we want to do. Hopefully that makes things a little bit clearer. All right, good luck.